Yes, we have arrived
We are
at
above.
water treatment plant. Yes, that's the entrance. That's the company. I think Auslung Wasser. That's the company called here. So you can see the name. We're basically just entering in. So this is a water treatment plant. You. They have something to show us at the beginning. So how they really process things. This is a dam which we saw early on, and that's the reservoir coming from the dam to the water treatment plant, and it's about 7 or 7.5 kilometers away from the dam. So they get water from the dam in order to filter it and to provide for drinking. Yes, here you can see some pictures. It's a dam. So this is a piece of a pipe or maybe a piece of turbine. I'm not too sure what it is. Yes. And this is a tunnel in the picture. We've been through to this tunnel early on, and here you have an overall view. This is our area. Three, four, then we have 6 parts. So we have got some people here. They are investigating the pictures, looking into it. That's the one. Drinking water and energy. Yes, drinking water and energy. That's the dam. This is a turbine we saw earlier. Yes. This is filtration. This is basically the process how they clean the water. This is a water treatment plant. Basically filtration. You can see here. This is I presume this is sand filtration. This is sand particles.
To the reservoir. Yes. And over there we have this big well. It was in order up to 10 or 15 years ago. It's the largest we have. It's 1.2 diameter. Pardon? This is we call it Ringkolbenventil. That means there's a valve for also the speed of the water, the amount of water, and the pressure. So,
Butterfly guy?
no, not butterfly. Butterfly means this way, and here we have this a kind of cone. This closes when it's moved in this direction. Yeah. And you can see here when the water comes through here, and then on the other side there's a cylinder that's drawn out and closes the surrounding there. So the water normally goes around this special inlet there. And the maximum speed would be 40 kilometers, the water going through this. And that means up to 16, 17 cubic meters per second through this valve. And this was the valve at the bottom outlet. And as you can see, there is some corrosion over there, and so we renewed it somewhere, and there's a new one at the bottom outlet today.
Corrosion is
We
because of
have this here.
pH of water, yes? pH of water.
The pH, we have pH 7.0.
That's because they.
No, it's because of the speed. The speed is very high, and so small particles they just drop this inside sealing, and so there's some corrosion then afterwards.
How long would it take for it to can't be used anymore? I mean, what's the lifetime of the valve?
The lifetime of this valve would be up to 50 years. Should be because it's very expensive. This one costs a new one with the motor. It costs about 250,000 euros. About, yes. It's a very special one, and they just build it for this special type, for this special situation.
And since it's like a cone, the pressure and the speed of the water would be higher on the other side.
Right. Yes, we have. Right, we have the pressure of the reservoir, and that means 6.5 bar on this side, and on the other side there's 0. Well, yes, this is the special thing of this valve. Okay, so we can go in. We have a room there, and I can show you a picture show that takes about 18 minutes, I would say. And it's about the Harz Mountain, and it's about the special things of this point here with the Grane Dam and its waterwork. And we have a central laboratory here for the measurement of the water quality. And well, some things about the hydrology of the Harz Mountains, yes. So you can see, I will show. Yes. Please follow. Well, our company, the Harzwasserwerke, was founded in 1928, so we're 90 years old. And it was founded because of the floods in the Harz Mountains on those days. And the government of, well, it was Hanover at that time, they decided to build dams and to catch the high waters. And the first one was built in Osterode, it's on the south side of the Harz Mountains. And it's called the Söse Dam, and it's built with a concrete ceiling in the middle and with like a real dam with earth on each side, on the water side and the air side, we call it. And it was fixed in 1931 and started. And as they recognized the water of being very, very good in quality, and there were some epidemics or some illness because of bad water in the area of Hanover, they asked whether they want to have this water for water supply there. But they already built own waterworks, so the water from the Söse was sold to Bremen. Well, as you maybe know, Bremen is about 200 kilometers in the north. And so, in these days, they bought pipes and fixed the pipe from Söse up to Bremen, and the water going by its own gravity, because it starts there at 270 meters over zero, and in Bremen it's 27 meters. So there's a difference. This is enough for the water going by its own. And this pipe they built on those days is still in order today, because of good maintenance, maybe. But we have a special program to renew it. And after that, some other dams came, they built some other dams and also waterworks. And the last one was here at Grane. It was in 1969. Well, some of this is also in our picture show. Our company was founded by the government of Lower Saxony, and it belonged to the company of Lower Saxony until 1997. So just 25 years, 20 years ago, 21 years ago. Our Prime Minister, the Prime Minister of Lower Saxony, he decided to sell this company because it was quite good and it seemed to get a lot of money. And we were sold on those days, the price was 110 million euros. And it was sold to our customers. The companies who got the water and gets the water today from us, they are our owner. This is quite a difficult situation, as you recognize quite quick. On the one hand, they are the owner of the company and want to have a profit. And on the other hand, they are our customers and they want to have a low price. And so this is a very, very hard job to do. And this is my job today. I started here as an engineer for several parts of the water treatment. And then I was for 12 years. I was the engineer engineer for all the waterworks here in Harz Mountains. And in the last 4 years, I'm doing now the selling of our water and all that stuff with our customers. Well, the owners are companies like Purena. It's a big company in the north here, and they give the water to smaller towns. And it's also a company in Bremen and in Braunschweig, and some other smaller Stadtwerke. Could you help me? What's the English expression of it? Stadtwerke. That means the company in a town which makes the water supply in the town. These companies are our owner. So this is quite special. Okay. So I start the film.
When the day begins for around 2 million people in southern and central Lower Saxony, they help themselves to something priceless, a product which has become indispensable for everyday life: water. For the people between Wolfsburg and Braunschweig, Hildesheim and Hanover, it isn't just any water. It's water from the springs and streams of the Harz Mountains. Water flowing from the northwest of the Harz Mountains is collected in the Graune Reservoir. Some of this is treated at the waterworks, while a substantial proportion of the water that flows into the Graune Reservoir is discharged back into the Graune further upriver. A concept in harmony with nature.
There are 6 reservoirs in the western Harz Mountains, and at 3 of these there are waterworks producing drinking water, just like at the Graune Reservoir. This is where the waterworks with the largest output was built, because at the beginning of the 1960s it became apparent that there would be an increase in water consumption during the coming decades. The plans for the reservoir were not received positively by all sections of the community. Popular footpaths and the traditional Forester's Lodge were in the area to be flooded.
Work on the reservoir began in 1966. The forest in the area to be flooded had to be cleared to make way for the new reservoir. Earthworks raised the dam, built of gravel, slate and diabase to a height of over 60 meters. The water side was sealed with a layer of bituminous concrete. The the reservoir was completed in 1969. Then work started on the waterworks. Large halls were constructed to house the water treatment plant. Enormous pipes had to be fitted with millimetre accuracy. At the same time, the two long-distance water pipelines, with a total length of 90 kilometres, were also laid.
At last, on the 13th of July 1973, everything was ready, and there was a ceremony to mark the opening of the waterworks and the long-distance water pipelines. In order to provide the Hildesheim-Hanover area with extra water from the Harz Mountains, the West Grane long-distance water main was joined to the Zirzer long-distance pipeline, which at that time was working to full capacity. Since 1943, a long-distance water pipeline has run from the Oker reservoir to the town of Braunschweig and on to Wolfsburg. Now it's supplemented by the East Grane long-distance water pipeline. Since this was laid, Braunschweig has been almost exclusively supplied by the waterworks of the Harz Wasserwerke. The Volkswagen plant is one major consumer connected to the network. But many small towns and villages in the northern foothills of the Harz Mountains also receive water from the Grane. As well as this, numerous water supply companies take the water and supply it to every house. Many of these companies use water from the Grane to supplement their own sources of drinking water.
For the customers, pure, fresh water from the tap is just as natural as electricity from the socket. In the first 25 years of operation, the Grane waterworks supplied approximately 1 billion cubic meters of drinking water. But where does the water for the Grane reservoir come from? And how is it treated at the waterworks?
The Grane is an idyllic river, which, as opposed to most of the other rivers in the Harz Mountains, rarely floods. This means that the volume of water in the Grane is not sufficient to fill the reservoir. Therefore, water from the Oker reservoir is diverted into the Grane reservoir. This is done particularly during times of flooding. The 7.5 kilometre long Oker-Grane tunnel serves this purpose. The Innerster reservoir in the neighbouring valley to the west also makes a contribution. Water from the Innerster reservoir is pumped through a pipe over a 100-metre high peak into the Grane reservoir. Excess floodwater from further rivers such as the Radau and the Goza is diverted into the Grane, which then serves as a source of drinking water. In this way, an annual average of approximately 40 million cubic meters are obtained from the surrounding area. This shows that the Grane reservoir is not simply a reservoir for drinking water, but also provides protection against flooding. A large region is thus protected from damage. Intake and output are constantly monitored, as seen here at the Herzog-Julius-Hütte gauging station. Controlling the output of water, particularly in dry periods, has a positive influence on the ecological balance of the rivers. The Grane reservoir has a capacity of 46.4 million cubic meters. This volume is roughly equal to the amount of drinking water produced annually by the Grane waterworks. But how is this done?
At the foot of the dam there are pumps to draw off the water. The water is fed through two pipes, each with a diameter of 1.2 meters, right under the dam, via a pumping station, and into the service reservoir, the daily storage basin. This lies above the waterworks. From here the water can flow through the entire treatment process only by gravity. It's only natural that the reservoir water is somewhat impure. Therefore, it has to be filtered and disinfected. From the daily storage basin, it reaches the first filtration stage via a pipe. This stage involves 20 tanks situated in a large hall. In the reaction tank, aluminium sulfate is added to the water as a coagulant. The formed flocks, which include turbidities, algae and iron, can be filtered off. In each filtration tank, there is a 1.8 meter deep layer of sand. When the water trickles through this fine sand, the flocks are removed from the water. The water is collected in the pipe duct and fed to the filtration tanks of the second filtration stage, which is situated directly underneath the first filtration stage. First, lime water is added to the water in the reaction tank. This increases the pH value, and the manganese is removed from the filters so that it's not deposited in the pipeline during transportation. Drinking water from a surface waterworks like the one at the Grana reservoir must be disinfected. Hartswasserwerke uses chlorine gas for this. The final stage is the clear water tank in the basement of the waterworks. From here, the drinking water flows into the long-distance water pipelines. The operations of Hartswasserwerke can therefore be summarized in 3 words: collect, treat, transport.
Back to the waterworks. The substances left behind in the sand filters of both filtration stages must be removed regularly. The filter sand must be backwashed, as the waterworkers call it. This is carried out separately for each filtration tank, using a counter-current of air and water. The pipe system is switched over and water is forced upwards through the sand, washing the blocks along with the residue, into a sedimentation tank. The residue settles out and the clear water runs into the Grana.
In 1998, in this building next to the waterworks, Hartswasserwerke put into operation some of the most modern technology for treating filter backwash residuals in compressed solids. The damp residue left behind in the sedimentation tank is transported through pipes to this facility. The residue is then dried and compressed into small pellets in a series of fully automated steps. These pellets constitute a completely harmless substance which can be disposed of at a domestic landfill site or used as an additive in the brick manufacturing industry. The plant at the Grana reservoir includes one important facility of the Hartswasserwerke.
It is the central laboratory. Here specialists ensure that the quality of our water is monitored from its sources and intakes right up to where our customers need it. This does not just apply to the areas of the Grana reservoir, but also to the other reservoirs, the 4 groundwater waterworks and the transportation through the mains network of Hartswasserwerke. The water is monitored at a total of 510 sites. It's our duty and our job to provide and guarantee quality at all times.
3 ships, supervising the waterworks around the clock, are responsible for the correct operation of all plants of the waterworks and the reservoirs. The emergency crew is responsible for ensuring that the long-distance water pipelines remain in perfect working order at all times.
The whole system of pipelines is kept under surveillance using modern remote control systems. Even the seals in the pipes in the different areas are monitored by remote control. At the Grana reservoir, not only drinking water is treated, we also generate electricity when water is given to the Grana. The Oker reservoir is also equipped with a turbine and a generator to produce electricity.
Electricity is also generated where no one would expect it, at the elevated tanks of the long-distance pipeline network. To do this, we use the pressure created in the pipes on their way from the mountains to the plain. Turbines driven by the constant flow of the water are installed here. Drinking water creating energy without fumes or radioactivity. The special turbines pose absolutely no threat to hygiene. Despite all the technology we have in our pipelines network, it still takes second place to nature in summer, as in winter. The area around the Grane Reservoir is designated as a drinking water protection area. This sign is intended to remind hikers of the necessity for the restrictions.
The clear water you see hereabout, dear hiker, please watch out, is drinking water of high quality, which flows from here to town and city. The best filter won't help, we fear, if the water gets dirty here. If you pollute it, just you think, you could soon end up in clink.
These strict drinking water protection regulations are only necessary to a lesser degree at the neighbouring Oker and Inister reservoirs, offering ideal conditions for sailors. On the Oker, whitewater canoeing is possible along a roughly 1 kilometre stretch between the power station and the basin below. The Oker Reservoir Power Station creates small, planned floods at certain times. These are even exploited for national competitions. Angling clubs enjoy the artificial lakes. Only the fish look somewhat down in the mouth. They would have preferred to stay in the clear water. Cyclists and hikers use the works, roads and forestry paths around the reservoirs to enjoy the fresh air of the Harz Mountains and find time to relax.
Humankind, nature and technology can be in harmony. The Harz Wasserwerke dedicates itself to the task of supplying drinking water to its customers on a sustainable basis and with foresight. Our success is, however, also dependent on the good sense of visitors to the Harz Mountains. Only if they treat the countryside, streams, rivers and reservoirs with respect and don't cause pollution can there be a guarantee that we will be supplied with something precious that serves us every day. Refreshing, clear, pure water.